Imagine that you're in another world, where the sky burns with the crimson hue, and the landscape consists of endless stretches of rust-colored plains and towering volcanoes. This is Mars, our neighbor in the solar system, a planet that's captivated our imagination for centuries. But what do we really know about this alien world? From ancient astronomers charting the night sky to modern Mars rovers traversing its rocky terrain, Mars has always been a source of mystery and fascination. Its elusive nature has sparked countless debates and inspired many science fiction stories. But what if we told you that the real story of Mars is even more intriguing than any fiction? On this journey, we're going to delve into the never-before-seen, unseen realm of Mars, which is beyond the reach of our human eyes. We're going to explore Mars as we have never seen it before, through the prism of ultraviolet images. Today, we take a journey with NASA's MAVEN spacecraft, which has been studying Mars from orbit since 2014. We'll learn how it peeks into the Martian atmosphere, capturing images with wavelengths beyond the visible spectrum and revealing secrets that have been hidden for ages. History of Mars exploration. Our journey to discover Mars did not begin with high-tech spacecraft and advanced imaging technology. It began centuries ago with curious minds and rudimentary telescopes. Ancient astronomers were the first to chart the path of Mars across the night sky, noting its distinctive reddish hue. But it wasn't until the invention of the telescope in the 17th century that we first saw the red planet. Early observers noticed polar ice caps and dark areas, which they mistook for seas and continents. As telescopes improved, so did our understanding of Mars. The 19th century brought us the infamous channels of Mars, a misinterpretation of surface features that gave rise to wild theories about Martian civilizations. Let's go back to the 20th century, to the dawn of the space age. Mars became a prime target for exploration. The first successful flyby was NASA's Mariner 4 spacecraft in 1965, when it sent the first up-close images of Mars. Since then, an entire fleet of orbiters, landers, and rovers from various space agencies have taken on the role of exploring Mars. Every mission, every technological leap has brought us closer to understanding Mars. One of the most significant advances in Mars exploration has been the development of imaging technology. From grainy black and white photos of Mariner missions, we've moved on to high-resolution color panoramas, infrared, and even ultraviolet images. Ultraviolet imaging, in particular, has opened a new window on Mars. It allows us to see what our eyes cannot see: the complex interactions between the Martian atmosphere and solar radiation. This brings us to the MAVEN mission and its ultraviolet imaging spectrograph. Known as IOVS, an instrument that's revolutionized our understanding of Mars. MAVEN, so we've already established that in the grand race of Mars exploration. One mission stands out for its unique approach to unlocking the secrets of the red planet: NASA's MAVEN. Launched in 2013, the Mars Atmosphere and Volatile Evolution MAVEN project had a single purpose: to study the upper atmosphere of Mars. Unlike rovers that explore the Martian surface, MAVEN revolves around the planet, closely examining the thin gas veil that covers Mars. Since 2014, MAVEN has been diligently observing the Martian atmosphere, focusing on its interactions with the Sun and the solar wind. These interactions are key to understanding how Mars lost much of its atmosphere over time, transforming from a warm and humid world to a cold, barren planet that we see today. At the heart of the MAVEN mission is a remarkable instrument, the Imaging Ultraviolet Spectrograph, or IOVS. This device doesn't just photograph Mars. It captures invisible ultraviolet light, invisible to our eyes. In the context of Mars, ultraviolet light is particularly important for studying the planet's atmosphere. When ultraviolet light from the Sun enters the Martian atmosphere, it interacts with the gases there, causing them to glow in the ultraviolet spectrum. The IOVS measures wavelengths from 110 to 340 nanometers, well outside the visible spectrum. This is akin to discovering a new dimension of observation, giving us access to an area of information previously inaccessible. But how do we make sense of this invisible light? How can we translate it into something we can understand? The answer lies in the magic of color processing known as image formation in false colors. Different wavelengths of ultraviolet radiation are assigned colors within the visible spectrum when displayed in artificial colors. In the case of IOVs, 3 specific ultraviolet wavelength ranges are represented by red, green, and blue, primary colors of light. The shortest wavelengths, about 110 nanometers, are represented by blue. Mid-range wavelengths, about 180 nanometers, are represented by green. And the longest, up to 340 nanometers, are red. By assigning colors to these wavelengths, we can create images that reveal complex details of the Martian atmosphere. But it's not just about color. The brightness of each color in the image corresponds to the intensity of the ultraviolet light. Brighter areas indicate higher intensities, which means a higher concentration of the gas or element the IOVs is observing. By combining these colors and brightness levels, IOVs creates a comprehensive picture of the Martian atmosphere in ultraviolet light. It's a bit like painting, but instead of oil or watercolor, we use light of different wavelengths and intensities. These images are not just beautiful. They're also incredibly informative. They show us the distribution of various gases in the Martian atmosphere, the effect of solar radiation, and even the effect of dust storms on atmospheric loss. Through the IOVs lens, we see Mars in a whole new light and get closer to answering the age-old question, what happened to Mars' atmosphere? UV images, theme of an mission, has provided us with truly stunning images of Mars taken in ultraviolet light. These images, taken at different points in Mars' orbit around the Sun, offer a unique perspective on the red planet and the changing seasons. The images taken by MAVEN at different times of the year show dramatic changes in the Martian atmosphere. They show how the distribution of gases, such as carbon dioxide and ozone, changes with the seasons, similar to the changing colors of leaves on Earth. This first image was taken in July of 2022 during the summer season in the southern hemisphere. This occurred when Mars is closest to the Sun. The tilt of the planet's axis of rotation causes summer in the southern hemisphere, similar to the change of seasons on Earth. In this image, we see the Argyre Basin, one of the deepest craters of Mars, filled with an atmospheric haze depicted in pale pink. The deep canyons of Mariner's Valley are filled with clouds colored tan. The South Polar ice cap, highlighted by a white spot below, is shrinking due to the relative warmth of summer. The second image was taken in January 2023, after Mars had passed the furthest point of its orbit from the Sun. This image captures the northern hemisphere of Mars, where rapidly changing seasons cause an abundance of white clouds. The deep canyons of the Mariner's Valley can be seen highlighted in tan in the lower left corner, along with many craters. Ozone, which is shown in magenta in this UV image, was formed during the polar nights of the northern winter. It's worth noting that the imagery produced by the orbiter provides valuable information about the atmosphere of Mars and its interaction with solar radiation. Atmosphere. Different colors represent different elements and compounds in the atmosphere, and their distribution gives us an idea of the Martian climate and weather conditions. For example, the purple areas in the image represent ozone in the atmosphere of Mars. The white and blue areas represent clouds or haze in the Martian sky. The planet's surface appears brown or green, depending on how the images have been optimized to enhance contrast in detail. These images also show the effects of solar radiation on the Martian atmosphere. Bright spots in the images indicate areas where the atmosphere responds strongly to solar radiation, indicating the atmospheric loss rate. In addition, MAVEN images have given us a unique perspective on the Martian dust storms. These storms, which can engulf the entire planet, significantly impact the atmosphere. MAVEN images show how dust particles rise into the upper atmosphere, affecting their composition and behavior. As we marvel at the stunning ultraviolet images of Mars and the wealth of information they provide, it's interesting to think about what the future holds for Mars exploration. The MAVEN mission has already greatly advanced our understanding of the Martian atmosphere and its interaction with solar radiation. But this is only the beginning. Data and images from MAVEN will continue to be analyzed and interpreted, eventually leading to discoveries. As for example, in the case of Venus, unexpected and impressive discoveries can be made even by studying data from 30 years ago. By the way, we have a separate video about this. One of the most important implications of MAVEN's discoveries is their potential for use in future Martian missions. By understanding the Martian atmosphere and its changes, we can better plan future robotic and human missions to Mars. For example, understanding Martian weather and atmospheric conditions can help design spacecraft and equipment that can withstand harsh Martian conditions. It can also help select the best landing sites for future missions. Moreover, MAVEN's findings about the loss of the Martian atmosphere may provide clues as to whether the planet was habitable in the past. This may help in the search for signs of past life on Mars, which is one of the goals of upcoming missions. Looking even further into the future, we can imagine a time when humans will set foot on Mars. The knowledge gained from the MAVEN mission and others will be crucial in preparing for this monumental step. In fact, the question of what it will take to establish a human presence on Mars is a topic we've discussed before, shedding light on the challenges and opportunities that lie ahead. As we continue to explore Mars, we can expect the development of even more advanced imaging technologies. They could reveal even more details about Mars, from its subsurface structure to the composition of the tiniest dust particles. The path to understanding Mars is long and difficult, but with each new mission and each new discovery, we get closer to unlocking the mysteries of the red planet. And who knows, maybe one day we'll be able to see Mars not only in ultraviolet light, but also with our eyes from its surface.